New features in TINA Design Suite version 15 and TINACloud. Welcome to TINA Design Suite version 15 and its online version, TINACloud. TINA 15 is a major upgrade with plenty of new important features. Let's see the most important ones. Built-in artificial intelligence tools, AI.
AI tools in TINA and TINACloud offer a flexible, user-friendly interface for various engineering tasks, including circuit design, simulation, code generation, and education such as providing information on circuits, designing LDO and SMPS power supply circuits, designing active and passive filters, designing analog oscillators and digital clock generators, selecting and redesigning evaluation circuits from different manufacturers, generating Arduino code for rapid prototyping, image recognition with Python or MCU, creating step-by-step solution of simple DC-AC circuits, creating quizzes and riddles and check their solution. The AI support in the offline TINA provides flexibility and privacy. You can use local AI models to design and simulate circuits locally without relying on internet connectivity or leverage the power of cloud-based AI services. Here are a few examples. Providing information and redesigning a switch mode power supply in TINA. Setting the output voltage to 3 volts. Due to the AI capability using natural language to interact, you can word your request in many different ways and languages. This time enter, now change the output voltage to 8 volts. The redesigned circuit provides the requested 8-volt output voltage. Presenting a Colpitts oscillator circuit and providing information in TINA. Enter this, set the frequency to 1 MHz. The redesigned circuit oscillates with the requested frequency. Generating Arduino code for rapid prototyping with AI in TINA. Enter the following request in AI Assistant. Create a simple Arduino code for generating prime numbers up to 100. Copy the code into the TINA Arduino code editor, then compile and save the project. Check the result with interactive transient analysis, using the serial monitor tool. The list of generated prime numbers appears on the screen of the serial monitor. Creating a step-by-step solution of simple DC-AC circuits in TINACloud. As you can see, TINA's AI-powered analysis, using fundamental circuit theory, delivers results that precisely match numerical simulations, provided by the interactive DC analysis tool of TINA. TINA and TINACloud AI helps you create quizzes for any circuit. Just provide the circuit name for well-known ones, or add a title and description for less familiar circuits. AI analyzes your request and provides a detailed summary of your learning progress. In case of a correct answer. In case of a wrong answer. After 5 questions, finally the evaluation. You can also create riddles on electricity and electronics. Let's see a few riddles generated by TINACloud. You can test your knowledge and rack your brain over my tricky riddles.
Okay, can you create a simple riddle about electricity, please?
I flow through paths both short and long, my strength depends on where I belong. In a loop, I must return, or else my power you will spurn. What am I?
Voltage?
Not quite. Here's a hint. Think about what must continuously move through a closed loop in a circuit to ensure everything functions properly. This flow is essential for the operation of any electrical device. What am I?
Current.
Correct, well done. The answer is indeed current. Explanation: in an electrical circuit, current is the flow of electric charge. It must travel through a closed loop or circuit to power devices. If the circuit is open, the current cannot flow, and the device will not function. This concept is fundamental to understanding how circuits operate, as current is the lifeblood that powers all electrical components.
Okay, but that was too easy. Can you make a riddle about semiconductor devices?
I'm a gatekeeper with 3 legs, controlling flow with a tiny nudge. I amplify signals, small to grand, and switch with ease at your command. What am I?
Bipolar transistor.
Exactly right. Congratulations, the answer is a bipolar transistor. Explanation: a bipolar transistor is a semiconductor device with 3 terminals, the emitter, base, and collector. It acts as a gatekeeper by controlling the flow of current between the collector and emitter, based on a small input current at the base. This allows it to amplify signals and switch them on and off, making it a crucial component in many electronic circuits for amplification and switching applications.
AI image recognition using Python and MCU code. Image classification is a task of assigning a label or class to an input image. In TINA, it is realized with Python using convolutional neural networks, CNNs. For more information, see New components from Infineon Technologies, Texas Instruments, Nishinbo Micro Devices, Worth Electronic, ST Microelectronics. New simulation and analysis features. Component activation, deactivation. Fourier spectrum processing in the interpreter. Diagram processing functions, filtering and smoothing. Advanced multisign analysis with pulse response. New oscillator and timer circuits. And more. Enhanced with these great features, TINA can help you even more to advance your ideas and your product definition. New features in TINA Design Suite version 14 and TINACloud. Welcome to version 14 of TINA Design Suite and its online version TINACloud. TINA 14 is a major upgrade, with plenty of new important features. Let's see the most important ones. New components. In TINA 14, lots of new analog, digital and mixed signal components are available from various manufacturers including ADCs, DACs, microcontrollers, voltage references, gate drivers, DC-DC converters, sensors and more. TINA 14 also has a variety of new analysis modes. Multisign simulation, piecewise linear PWL solver, new RF components and their analysis, circulator, 3 and 4 port directional couplers and more. User-defined fast analytics solver for SMPS and other devices in both interpreter and Python. 7 HDL languages, vhdl, vhdl-AMS, Verilog, Verilog A, Verilog AMS, System Verilog, System C. And this isn't all. TINA v14 in version 14.1 also has faster solution algorithms, inverse Laplace transform, full Python programming language for additional calculations, post-processing and more. Online DC and AC circuit analysis course, using either Python or TINA's interpreter. Python support in the design tool, DC-DC converter application circuit search. You can also learn more about TINA from the new TINA and TINACloud ebook, 440 pages, with tutorial videos. Also, TINA v14 now runs on Mac with one-step installation, including Wine. Let's look at some of the features in more detail. Multisign simulation. Multisign analysis calculates the frequency response of circuits, without linearization, using transient analysis with a special excitation, consisting of multiple sinusoidal, so-called multisign voltages. This is especially useful with SMPS circuits, where AC analysis is only possible through special, so-called average models which cannot be automatically created, and for which, manual creation is quite laborious. In addition, multisign simulation is close to the real-life multisign measurement of transfer functions. Let's see an example. found in the Multisign folder of TINA 14. Select AC Multisign Analysis. In the AC Multisign Analysis dialog, among others, you can select the required diagrams, and set the steady-state time from where the multisign excitation is added. 3 diagrams will appear. Transient result with multisign excitation from 1.5 millisecond. Circuit response to multisign excitation. You can zoom in to see the circuit response in more detail. AC transfer amplitude diagram. Vhdl diagram. Piecewise linear, PWL solver. In V14, in addition to the SPICE solver, TINA also includes a piecewise linear, PWL solver. A unique feature of TINA is that in PWL mode, it automatically creates the PWL models from semiconductor and other non-linear SPICE models. This provides an up to 10 times faster solution depending on the structure of the SPICE models. You can find examples of PWL analysis with explanations in the Examples PWL folder of TINA V14. The solver for PWL analysis can be selected in the Options dialog of the Analysis menu of TINA. PWL analysis is also very useful for multisign analysis, as it shortens the transient analysis included in multisign analysis. To demonstrate the effectiveness of the PWL solution, let's load a startup transient example from the PWL folder of TINA. You can choose Newton-Raphson or the PWL solver in the Options dialog of the Analysis menu. Compare the result and execution time of both solutions on the screen. In this case, the PWL solution runs 4 times faster. New RF components, circulator, 3 and 4 port directional couplers. There are several new microwave components in TINA. Circulators are defined with main parameters, or with detailed manufacturer provided or measured S parameters. 3 and 4 port directional couplers can be defined similarly with main parameters, or with detailed manufacturer provided or measured S parameters, in touchstone format. Here is a sample of the manufacturer-provided S-parameter file in touchstone format. Let's see an example. VSWR, voltage standing wave ratio measurement, using the CP20408A10 4-port directional coupler defined with a manufacturer-provided S-parameter model. User-defined fast analytic solver for SMPS and other circuits in both interpreter and Python. For a wide range of power circuits, it is possible to obtain a fast, approximate analytic solution using either Python or the TINA interpreter. If an analytic solution is available for the circuit in the design tool, it is possible to obtain the results quickly as diagrams by running the Fast Analytic Solution command from the Analysis menu. You can also customize, refine, and apply the available solutions to similar circuits, or even create your own, to better suit your specific requirements. Fast Analytic Solutions with Python. When you select the Fast Analytic Solution command from the Analysis menu, the program will create efficiency, AC Vhdl, startup transient, and steady-state diagrams of the circuit. You can also obtain the same diagrams in the design tool. In this example, the program code is in Python. When you press the green Run button, the program will create the same efficiency, AC Vhdl, startup transient, and steady-state diagrams of the circuit. Now, let's see the same solution with TINA's interpreter. The program code is written in TINA interpreter. New HDL languages in TINA v14. From TINA 14 onwards, 2 new hardware description languages, System Verilog and VHDL AMS, are available. With these extensions, there are 7 available HDLs, in addition to SPICE. System Verilog. System Verilog is an extension of the Verilog hardware description language, also included in TINA. In TINA, System Verilog is automatically translated to System C, which can be compiled with MS Visual Studio, providing a very fast and optimized code. You can find several circuit examples in the Examples, HDL, System Verilog folder of TINA. Let's load a wave generator circuit in which a digital waveform is created with System Verilog. Note that the code in the macro is written in System Verilog. Let's run a transient analysis. Out shows the generated signal after ADC. The great advantage of TINA is that you can run HDL languages together with SPICE. Let's change the switch and see the waveform after the low-pass filter with the SPICE op-amp macro. Note that the op-amp macro is written in SPICE. Run transient analysis. Now, out is a smooth sine wave. VHDL AMS. VHDL AMS is an extension of the VHDL hardware description language, also included in TINA. It includes analog and mixed signal extensions, AMS, to the purely digital VHDL language, in order to simulate analog and mixed signal systems. You can find several circuit examples in the Examples, HDL, VHDL AMS folder of TINA. In this circuit, the same sawtooth wave is generated with 2 different circuit sections and methods. In the upper part, the counter is written in Verilog. In the low-pass active filter, the op-amp is written in SPICE. The lower part contains a VHDL AMS block that generates the same waveform. A great feature of TINA is that it can run all HDL codes in SPICE, as well as MCU codes together. Inverse Laplace transform. You can define linear circuit components with Laplace transform, voltage sources, current sources, transfer functions, and more. Now these components can be used in both the time domain, using inverse Laplace transform, and in the frequency domain. You can find examples in the Examples, Laplace folder of TINA. Let's demonstrate this through a simple RC integrator circuit. In the Laplace subcircuit, the transfer function of the RC circuit is given with the standard SPICE Laplace function. Run transient analysis. The upper curve shows the result of the numerical solution of the state equation of the circuit, while the lower curve shows the result of numerical inverse Laplace transform. The 2 methods provide the same results. Embedded full Python programming language in TINA, for additional calculations, circuit design, and more. In addition to the interpreter, the Python programming language is also available in v14 of TINA. Python is a modern, high-level, general-purpose programming language with extensive libraries and a lot of free programs, available for various topics that can now be used in TINA. You can find use examples in the Examples Python and Examples Design Tool folder of TINA. To get started, TINA includes Python shell with a short bubble sort sample program to play with. Analyzing an RC circuit using Python. In this example, We will draw the body amplitude and phase characteristics of the RC circuit on the screen using Python. Online DC and AC circuit analysis course, using either Python or TINA's interpreter. Now, all the solutions to the examples in our free DC and AC course are also provided in Python. Python support in Design Tool. Design Tool is a unique and powerful tool in TINA that works with the design equations of your circuit to ensure that the specified inputs result in the specified output response. The tool offers you a solution engine that you can use to solve repetitively and accurately for various scenarios. The calculated component values are automatically set in place in the companion TINA schematic, and you can check the result by simulation. This feature is also very useful for semiconductor and other electronics component manufacturers to provide application circuits along with the design procedure. Now, you can add design procedures to your design using the standard Python programming language as well. You can find application examples in the Examples Design Tool folder of TINA. Let's see an example. The output voltage of this circuit is 5 volt. Now, let's specify output voltage as V out equals 3 volt. In this design, the design procedure is described in Python. You can modify or write a new one. Close the Python code window by clicking Laas, and then pressing the green Run button. The program will draw the calculated efficiency, body, startup, VCC ripple voltages, and the redesigned component. Now, the output voltage is the specified 3 volt. The redesigned value of our FB1 is 2.75 K. You can save the redesigned component values to the circuit by pressing the Save and Close button. Enhanced with these new features, TINA can help you even more to advance your ideas and your product definition. That wraps up our summary on the new features delivered with TINA 14 and its online version, TINACloud. For more information, visit our website, tina.com, and visit our YouTube channel, youtube.com/user/TINA Design Suite.